Okay.
Hello and welcome, everybody. You want to start?
Maybe. So, welcome everyone to the OAI webinar series, chapter 12. Today's webinar is the overview of F1 and E1 in OAI and F1 handover, presented by Robert Schmidt, so the OAI RAM team lead. So maybe Robert, if you want to say a couple words about yourself, I would let you talk right now.
So yes, thank you, Camille. Hello and welcome, everybody. So as you already said, my name is Robert Schmidt. I'm RAN team lead and senior software engineer at the OpenAirInterface Software Alliance since now 3 years. I worked a lot, as we will also see, and that's why I'm doing this presentation on F1, also a bit on E1, and in general some splits. So right now I'm working also on FFAPI and NFAPI, and yeah, then various things, RC, Mac, and so on. And as Camille already said, and let me now actually share my screen, and then maybe I will just stop this video so you see hopefully the screen properly. Yep, you should see the slides. And as you already said, so today another webinar, chapter 12, overview of F1 and E1, and then I will of course talk a little bit about the F1 handover that we have since a couple of weeks. Yes, so I will start with a motivation. What is F1? What is E1? Maybe many people actually know this, but I think it's good to make a recap and see where we are coming from. I will then talk a little bit about the F1 and the E1 interfaces, so what they do and what is in there and what are the messages and so on to get some basic understanding. Then I will, not in too much detail, but I will of course talk a little bit about the implementation status, so how this works in OAI, how this is implemented. Then towards the end, there will be two small demos. So the first one will be to just show how F1 and E1 work, also with multiple DUs and COUPs. And the second demo will be handover. And well, then in the slides, I don't have the exact instructions, but basically that orients on some Docker Compose files and also tutorials. And the demos that I will show, they use RF Simulator for those who know. So it should be fairly straightforward for those who watch now to then also reproduce these demos in their own laptops. And then I will conclude with an outlook on some future work that we will be doing. And that's it. Yes, if people have questions, then maybe I would suggest you write this in the presentation. And if there's some time after each section, I can maybe take a moment to answer those questions. And anyway, after the presentation, of course, we can answer more questions. So we'll try to leave 5-10 minutes so that we can answer if there are questions. So let's start. What are the F1 and E1 splits? So I guess everybody, or at least most of the people here, have seen a figure that looks something like this. So basically what this shows is a G0 B that is split into the CUCP that basically hosts the RRC, and it is connected via the E1 interface here to the CUUP, which basically is the user plane part. CP is control plane, so the centralized unit, and then control plane and user plane part. And then we have the DU, the distributed unit that hosts the RLC, the Mac, and Hi-Fi. And then using the frontal, we get towards RU. And so between the control plane and part of the centralized unit in the DU, we have the F1 control plane and the F1 user plane here on the bottom. So basically all the control plane decisions are done here on the top, and all the user plane that goes to the bottom. So, and basically, I mean, just also from a high level point of view, maybe I've seen this figure. So this, I think, is actually a figure that is fairly widespread, where you have the different split options. So sometimes you hear about the split 8 or the option 8, which is basically time domain samples that go out from the physical layer to the RF. Then you have this option 7. So here, this is why you have the frontal interface 7.2, because I think the ORAN split is a kind of a sub type of an option 7.
Wait, Robert?
Somebody's asking if the screen is shared.
Yes, should be shared. We see it here on the screen. It should be there.
Yes, screen is visible.
Thank you. I will continue in any case. Well, of course, it would be a bit of a pity to not have the slides, but we will put them online so you can still see the slides. And I guess there's also a recording, so probably this can be watched later as well. And yeah. So I was saying there is the option 7, then there's also option 6, also known as FAPI from the Small Cell Forum. And then we can go higher and higher. And then at some point we have the option 2, which is between the RLC and the PDCP, and option 1, which is between PDCP and RLC. And those two, they kind of translate to F1 and E1. And maybe let's also have a look at what 3GPP had to say about this. So this was something I went and digged a little bit, not too deep, but there's this technical report 38801, which was a study item where they actually studied this various splits that we have just seen, and there they actually discuss what could be done and so on. And in particular for the split option 2 and F1, what they said that this would allow traffic aggregation from NR and EU transmission points. Okay, that maybe doesn't say that much. What I found interesting, what is really written in there, is that this is the most straightforward option to standardize. So it was maybe easy for them to do compared to other possible option, and then also what already exists. So in particular, like front haul and FAPI, they already existed, but on the higher layers there were no splits. And then in general, I think what is quite, let's call it nice, is that everything that is real time, that is contained to the distributed unit further down, and everything that is not so real time constrained, like either just user plane forwarding or the control plane decisions on the CU. So that is kind of a nice split. So, and now just to say also maybe in a nutshell why now we do all this. So once more the same figure as before, but just in a little bit different arrangement. So we have always one CU-CP that is connected to multiple DUs via the F1 interface, and it also is connected to multiple CU-UPs via this E1 interface. And basically the F1 split in a way does centralization and some coordination. So we will see this later with the handover. Basically there is one CU and it's connected to multiple DUs, and then it can trigger the handover, and then basically the anchor remains. And via the E1 split, the CUCP can control various CUUPs, and then, for example, also do some kind of load balancing of the user plane, because of course, for multiple DUs, having everything go through one CU, this might be too much, and so on. And then, as I already said, the CU also has some kind of relaxed real-time requirements, what I said already here before, and this then also expresses in the fact that, for example, with the CU, it would be relatively simple to make cloud deployments and have this maybe somewhere, and then to push the DU further out towards the edge. So, and this is it basically for our initial motivation. Maybe the one thing that you should really keep in mind now is this figure on the left. So I won't repeat this multiple times, but when we talk about handover and so on, you should always think that on the top you have a CU, and this is connected to multiple DUs, and then a phone might be connected to one DU or another, and so on. So then I have just one thing, so we would also make an all-encompassing round about where we come from. So if we look in beginning of last year, basically there was already the F1 split or basic version. There was also the basic version of E1. There was even some interoperability with a commercial CU from Acceleran, but there were a couple of things that were missing. So in particular, UE capability did not work, and this is actually quite important in order to make like advanced things such as MIMO and 256 QAM and so on actually possible. So what, for example, was not possible until last year was to actually have high throughput, as far at least as we had it in OAI. Multi-DU handling was not possible. So in particular, it was not possible to do handover. Also, a re-establishment did not actually work. So that is all inconvenient. Of course, if you want to split your base station and it doesn't work, then in general, handover procedures and also the E1 support was a bit lacking. And the general challenge as of last year which has been overcome, as far as I would say, was that there was basically an old interface between, well, let's say MAC and RRC and also the PDCP, but this did a couple of things quite different than as they are specified in F1. And of course, if you want to specify or implement F1, then we should implement it according to the specification. And so basically what had to be done was to reorganize a little bit inside to actually put this overall F1 and E1 logic in the middle so that we could, for example, then split the base station and have this also work properly in OAI when we actually split the G0 B into the DU, the CUCP, and the CUUP. So, and now, before coming to this, let's, after this motivation, this introduction, let's have a look at what is F1, what is E1, and so on. And so I have here an example that is actually a figure that is directly from a specification. I think it's 38-401. And basically it describes how a connection setup happens for a UE that wants to connect to the G0B and then also connect to the AMF. And maybe it looks like quite a lot of things, but actually it's also quite simple in a sense, because basically in the beginning what the UE does, and which is not shown here in this figure, is that the UE in the beginning does random access at the DU. So this does the initial connection, let's say like this. And then at some point it will send an RRC setup request. So it tries to make an RRC connection, but the DU is not responsible for this. So this is the CU. So what happens here in the beginning is that there is what is called an initial UL RRC message where the DU tells the CU, okay, this is a new UE and I don't know that one. And then it connects or sends this to the CU, and then the CU starts to talk a little bit with the UE. So you can see that what happens here is just this downlink RRC message transfer and uplink RRC message transfer, where basically the CU just gives some messages to the DU and tells it to send something to the UE so that they can communicate a little bit. And once this RRC connection has been set up, then at some point the CU will say hello to the AMF and say that there is no new UE. And well, then there is this initial context set up, and then there is a UE context setup request. The one thing that I would like to say here is that this is one possibility how the initial connection can happen. It can actually be even simpler. So in particular, when the phone was in flight mode, then what happens typically, then you don't even have this UE context setup request in the beginning. You only see downlink and uplink and downlink and uplink and downlink and uplink RRC messages all the time. And at the end, the UE is RRC connected, but it doesn't have a PDU session. So the typical, in particular, when you use OAI in your testbed and you leave flight mode, then in the beginning, at the end of this exchange, there's no PDU session. So I will come a little bit at that in a moment and explain this a little bit more in detail. But typically what F1 does is mostly forwarding some RRC messages between the CU and the UE, and they agree on like maybe a couple of parameters, but that's mostly yes. So what are different F1 messages? So there are some messages to set up the actual connection between the DU and the CU, and then also maybe handle some error states with this reset and then the setup request and response. On the right side, we see all these RRC message transfer messages. So this is a group of messages that just says that the DU should forward something to the UE that the CU wants to tell the UE and vice versa. And then there is one group of F1 messages, which are the so-called UE context messages, management messages, sorry, where the CU tells the DU to either set up a UE context, but the UE context typically means to set up, well, a PDU session, or more precisely a data radio bearer. Then, of course, this can also be released, and then there are some messages for modification that will become, for example, relevant for handover. But for the basic connection setup, it's all very simple. Yes. Then, of course, we can have the same for the E1 messages. Actually, E1, I would say, is, I mean, relatively simple from the outset. All what happens is also that there's the setup request and response between the CUCP and the CUUP, where they set up the initial connection. And then basically, when there is a new PDU session, the CUCP will set up a new bearer context in the CUUP, and this can also be released. And sometimes there is some modification, but this often in at least OAI just means reset some counters and continue the connection. So in particular, E1 is relatively simple protocol. Of course, then there are intricacies in the protocol when you go towards more complicated use cases and so on. But in the basic case, it's relatively simple in the beginning. So, but then maybe let's look at a little bit more complicated case where also both F1 and E1 interact together to actually now set up a PDU session. So let's consider that in the beginning, we didn't have here this UE context setup request and the setup response. Basically, the UE connected in the beginning. There was some setup of security and so on. And at the end, there's no PDU session yet, okay? So in this case, there would only be uplink, downlink, RRC messages that are exchanged between the DU and the CU and nothing else. And now if we go forward, then the UE has no PDU session, but it needs a PDU session in order to forward a little bit of IP data. So what the UE then does is in NAS to send a PDU request, the actual message is called a little bit differently, but for all purposes, that will be enough. And again, we have the famous uplink RRC message. So there's nothing really that is to be done, which in turn is also forwarded by the CUCP to the AMF here. And it basically asks, or in this message, the UE asks the AMF to please set up a PDU session. And of course, the AMF is happy to do that. So it will accept this PDU session establishment request. And now actually let's say the real work from the F1 and E1 exchange starts to happen. So what happens typically in the beginning, the CUCP first will set up a bearer context in the CUUP. So basically the CUCP tells the CUUP, create a new PDU session. And of course the CUUP will do this and it will answer with, okay, I did this. And it goes back to the CUCP. So now the CUCP knows that this has been done. And it will then set up a UE context. By the way, sorry, that is a little bit mistake here. And it's a little oversight from my side. So this must be UE context setup. Where we now set up the first data radio bearer and also the signaling radio bearer 2 that always comes together. And basically the DU now creates a UE context. Of course, it's a little bit strange. Also, I found this a little bit confusing in the beginning because the DU knows already that there is a UE, but nevertheless, they now set up a UE context in the DU. So anyway, the DU will do this, it will answer this, then the CUCP just tells the CUUP that this has actually been also set up in a DU for some details that we can clarify later. And then finally, once all this has been done and the CUCP, the DU and the CUUP are okay, only then the CUCP will actually forward in, again, a downlink RRC message transfer. It will actually forward this NAS PDU session establishment, except that it received here in the beginning. It will forward this to the UE, and then the UE just says that this has been done. At the end, the CUCP also forwards this response to the AMF, and then finally the UE has IP connectivity, can exchange data, and so on. So also here, in the end, not too complicated. Maybe now let's briefly discuss why here, or no, I will, if somebody wants to maybe think a little bit and has an idea later of why there might be here this double exchange, let me know. I can maybe come back later to not go too much into various details now. So I hope that you got a basic overview over E1 and F1. So, but basically what they only do is to set up some UE contexts or maybe set up a bearer context for a PDU session. And these are the basic building blocks of which various things are done. And for example, also handover or reestablishment and so on. They just use these couple of primitives to then just agree between the DU and CU what needs to be set up. So all of these various groups are implemented in OAI. Then there are some procedures that are on top for re-establishment. The CUCP can handle multiple DUs, which then comes in handy to actually do mobility. And of course, on the other hand, also via E1, the CUCP can handle multiple CUUPs to, for example, do some load balancing for traffic of multiple DUs, or for example, do specialized handling for different slicing and all these kind of things. So that's the current status. Let's go forward. Yes, I wanted to talk a little bit about the implementation, so I don't want to go too much into the details, but maybe give a basic overview of how this is implemented in OAI. So I think I already mentioned this in the beginning. Basically, what OAI does internally, and in particular what RC and MAC exchange with each other, are basically F1 messages. So this maybe sounds a little bit strange at the beginning, but I will have an example in a moment on the next slide. But basically, there are C structures that are defined in a header, and basically, whenever, for example, the CU wants to send a message to the DU, it will fill the corresponding message structure, and then either it calls just down into the DU in a thread-safe way, and then the DU handles this message, or in the F1 case, there are some additional ways of forwarding this. But the basic thing, the basic message that I want to convey here is that even if you use monolithic, if the GNOB runs in one process internally, OAI will still use the F1 logic. So you have this uplink, downlink RC message. You also have the UE context that are exchanged. We have before seen that there's also bearer context. So also over E1, if the CU wants to, sorry, if the RC wants to set up a new PDU session in the PDCP, it will also use the E1 primitives. So how does this look exactly? So I now use the most simple case of the downlink RC message transfer that we have seen a couple of times. And on the top left, you basically see a screenshot of some code in the RC gnodb.c file. And basically what happens is that we look up some auxiliary data for, let's say, the F1 interface, which well, we need even if we don't run with real F1. So for example, we need to keep track of some IDs that are used in the DU and the CU. So this is what we look up in the beginning. Then there is just some validity check. Then we basically fill a C structure. We say that the current UE for which we want to send some data is a specific ID. And then we, of course, give what is the data that we want to send and what is the signaling radio bearer. And then we just call into a function pointer, and we say that this needs to go to a specific DU, so this is this association ID, and then a C structure. And if the RC now does this, then there is a function pointer. We go to one function, which is called DL-RC message transfer direct, which directly transfers via direct function call to the DU into this function, and then this, well, this buffer here will be put into an RLC buffer and then eventually be forwarded to the UE. So, and the basic thing that I want to say now, if we were to use F1, exactly the same thing will happen. Basically, we have exactly the same code here on the top, but now via the function pointer, we go to another implementation here, which in this case is called downlink RC message transfer F1 AP. What this message then does is it basically sends a message to the F1 subsystem. So for those who know, this is an ITTI message which we send from this function, and then eventually it will end up in a function called CU send downlink RC message transfer. This function actually will encode this message into ASN.1. So this is basically a format that is specified by 3GPP in order to ensure interoperability between DUs and CUs of different vendors. Then this is sent via a socket, and in the DU eventually it will be handled in this function DU handle downlink RC message transfer, and this decodes the message and then make a function call, and we are back into downlink RC message transfer. So also here, once more, basically the RC wants to send something down. It fills in some message definition and calls a function, but the RC doesn't actually really care how this gets down, and depending on which case, it will always end up in the same function, and then in the handler, it does various things. So for example, for the downlink RC message transfer, as I already said, it will fill this message into the RLC buffer, and then it will be forwarded to the UE. And the basic thing here also, so I said already that this is the simplest case in a sense with this downlink RC message transfer. So of course, for some other messages, for example, UE context setup, this will look a little bit more complex. The C structure will be a bit different, but otherwise it is the same thing. So now I said I don't want to go too much into details, but nevertheless, maybe there are some people who now would like to see a little bit how this has been done. So what I did here is I described a little bit the high-level milestones that we took in the last, let's say, 1.5 years. So there was one merge request that we had in our GitLab where we actually adopted this F1 setup procedure. So this one initial connection set up between the DU and the CU, and basically to use this internally also in a monolithic GNode B. This actually had two advantages of doing this. So it simplified a little bit the configuration, because before radio configuration needed to also be, radio configuration that actually pertains to the DU needed to also be present in the CU, but since that merge request, that's not the case. And then these UE capabilities that I mentioned earlier, that was basically the merge request that switched a little bit the logic and that set a couple of things straight, so that the CU does what the CU is supposed to do and the DU does what the DU is supposed to do, whereas before things were a little bit mixed and so on and really incompatible with F1. So this was the first thing. Then there were a couple of merge requests to adapt some UE IDs, because as I already said, the DU and the CU UE have different IDs that are used internally for reasons. For example, the UE chooses an RNTI and the DU chooses an RNTI randomly for UE. But if you have multiple DUs, then those might, and even though the chances are slim, they still might to choose the same RNTI. So the CU cannot reuse this RNTI. So there are a couple of things that needed to happen. And also in another merge request, the CU started to, or learned to handle multiple DUs. There was one merge request that adopted this E1 logic internally, also in monolithic, which allowed us to then, for example, also use multiple CUUPs. Then once these basic things were implemented, there was some work to actually do the re-establishment working properly, and to also actually align with an ORAN specification, which describes, or let's say, which clarifies how a couple of things need to happen within the 3GPP specification for F1 in order to make it ORAN compliant. So the 3GPP specifies F1, but ORAN also has a couple of specs that actually say, okay, specific things need to happen like this or that, so that it's done properly according to ORAN. This then also ensured some interoperability with custom off-the-shelf DU that we used. And then later there were merge requests to implement F1 handover, so we will see this in a moment, and more merge requests to actually do more unit tests to always ensure that what we give into F1 also comes out. So just make sure that what we send over the wire is also what we would receive. So I put this for those who want to have a look, so you can follow these numbers. If you have the slides later, actually those are links, and then you can look and read a little bit if you're interested, for those who want. So, and with this, I already conclude the first part. So we have seen a motivation of what is F1 and what is E1, what does it consist in. We have seen how a little bit of an exchange happened, and we have also seen how this is implemented in OAI. And as I said, I gave one example, the other messages, they are the same. So we have seen the basic building blocks. So the question, or my question now is if there are any questions by the audience that somebody wants to ask. Maybe in the chat. Camille, are there any questions in the chat?
No.
If there are no questions, then we can go forward. So I have basically two demos. The first demo is just basic multi-DU, multi-CU UP operation. And to also keep this simple, so basically what I did, what you would need to redo this demo is Docker, and that's all, and the Docker compose file. And basically what I chose here is what the CI runs in every merge request. So that is really a very simple case, but I would like to use this to show a little bit how this works. So what we do in the beginning, we just start the core network. So if you're familiar with OAI, I guess you have seen this. You will just wait a little bit to see that the core network is eventually started. So this takes a short moment. And on the right side, you see 3 windows. And basically what we will see here is the topmost will be the CU-CP, of which there will be 1 in the demo. And then we have in total in this demo 3 DUs and 3 CUUPs, and on each DU there will be also 1 UE, and basically the middle window will show 1 CUUP and the bottom window will show 1 DU. The UEs are not shown, and basically the other 2 CUUPs and the DUs neither, because they basically show the same, but yeah. And what we will do now, in the beginning, I start the CU-CP. I will show some logs, so just that we see what happens. So we see that there was the AMF that told us that the connection is set up. I start Wireshark so that we can maybe see some of the messages that we have seen before. So I just prepare for everything to happen in a moment. And if we now go back, what will happen next? I start the DU and also the CUUP, as we can see there in the logs on the bottom left, and the starts. So first of all, we see this in the CUCP logs that there's a new CUUP and a DU. And if we then also look into the logs of those 2 containers, we will see exactly that it has been started. And otherwise, also here, the periodic output of the DU. And now I will do the following, and I hope you can see this, that I started the UE on the bottom left, and we see now some output that happened all at once. So the UE connected, we see the periodical output, we see in the CUUP in the middle, as I had highlighted in a moment, that there is a tunnel and so on that has been updated to forward data, and also in the CUCP there's all this message exchange of how a new UE arrived in the beginning, and then the PDU session has been updated, as you can see there, and so on. And once this has been done, of course, we can inject some traffic. So the UE sends in the simulated environment some traffic, we see the ping. And if we now look in Wireshark, we see what we would expect and what I already mentioned. So in the beginning, we see that on the E1 interface, there was this E1 setup request and response where the CUCP and CUUP greeted each other, then the F1 setup request. Then we have a lot of this downlink, uplink, RRC message transfers. So that's what I said before in the beginning. There's just where CU and UE chat with each other and the DU just forwards those messages. And then eventually here there is an uplink RRC message transfer with some encoded message, NAS message that is encrypted, so we don't really see, but then eventually we see that there is some UE context setup request and a reconfiguration and so on in order to set up a PDU session. One thing, the F1 and E1 messages that you see here, they are not in the right order, so I don't really know, but the timestamps, they are better. For example, you see that here this bearer context setup that is marked in the video is at 26.90, so it should actually happen before the message that is here in packet 32. So I believe that's only because I actually traced on 2 interfaces at the same time. In the second demo, we will see this in the right order. Basically here we see the the connection, how it has been set up, some ping, so on. And now we can go forward. And for example, I can start a second UE, and because there's the dependency in the compose file, we see that it starts a second CUUP and DU in the bottom left, and we will then not see anything in the middle and bottom window, but in the top, for the simple reason that, as I said, you have multiple CUUPs and multiple DUs. So it started a new CUUP and a new DU to which the second UE was connected. Okay, and since there's only a single CUCP on the top, we only saw the output there. And of course, we can do again some ping traffic and so on. And do this also via the second UE. They all have traffic and so on. So this would be a very simple way of just playing with those interfaces. As I said, you could set this up yourself on your machine using Docker Compose, so you don't really need that much. You see here the message exchange with the second DU, pair or triple of DU, CUUP, and UE, and the only one that is the same is the CUCP, and that is why we always have this IP address 27.2 that we see here in the first UE, and that also happens all the time later on the bottom for the second UI context setup, so the same entity that is always the same is the CUCP. Yes, that's it.
So we have a few questions in the chat if you want
Yes.
to take time to answer.
Mhm.
So the first question is F1HO tested with real UI devices like Oppo phone?
Yes, it has been tested by me personally, I tested this with a Quectel and not with a real phone, and I actually tried with I think OnePlus Nord, and I didn't really make it work, but it has been tested by Smart quite a bit, so they tested this in their lab, and yes, it should work. And when I tested it, I said I tested it with the Quectel, but basically this is like a stationary setup in the CI, so I triggered the handover manually, as we will also see this in the demo in a moment, but it should work, yes.
The second question is neighborhood reported in measurement report?
No, I was made aware. So what we use currently for doing a handover when we use COTS UI is a so-called A3 event. So the A3 event is an RC event where the UI tells the CU that the neighbor is stronger than the serving cell. And basically, if the UI is configured to do such an A3 event, and if the CU receives this event, then it will trigger the handover. And I think the neighbor measurements are not reported yet, but I hope that is something that we can add soon.
Thank you. The third question is how far should 2B200 user P boards be kept for F1HO scenario?
That is something that I cannot exactly answer because it depends on many factors. So it depends, I mean, B210, or I don't know, 10, 20, 30 meters, something like this. Certainly not 2 kilometers and more than 2 meters as well. But I don't really know because then it depends on what are the antennas. Yeah. I would let's say like this, maybe try with 30 meters.
Okay.
And yeah.
Next question is why F1 procedure in monolithic mode is not a back disaggregated mode?
Yes, yes, that's actually a point that I went briefly over. So I already mentioned before that there was an old interface that was used between the Mac and the RRC that stemmed basically from the 4G times in OAI. And then there was an early version of F1, and the problem was that this was really put on top, and the F1 interface didn't work as the internal interface worked. And this created all sorts of problems where functionality of the CU has been duplicated in the DU and vice versa, and so on. And the simplest, in order to ensure that you use F1 in the CU and DU, is by adopting the logic and also using this internally. So basically, I at some point, let's say, made a decision. I don't know. I mean, in my opinion, it's reasonable to have like the basic logic between the RRC and the Mac to be F1. And for example, they use a downlink and then an uplink RRC message, and they use UI context message, and basically they talk like this to each other. And then if we want to disaggregate, we just need to encode the messages via ASN.1 and send to each other. And like this, we are basically sure that if it works in monolithic, there are very high chances that it will also work in split mode. And that's the basic reason why we use also these F1 procedures or the logic in monolithic. Does this make sense?
Yes, I think so.
Yeah, maybe not. I mean, basically, the answer is we use this in monolithic because then we are sure that it will also work in the split mode. Because the RRC and the Mac, they talk in terms of F1. So according to the spec, and if it works in monolithic, it will also work in split.
Okay, last question. I think Imran, your question was answered by Rafael. This one is reestablishment procedure support between DUs are supported?
I mean, what is supported right now is only a reestablishment on the same DU on which the UI was connected before. The spec says that in some cases, for example, if the CU doesn't know the UE that does a reestablishment, but also some other cases, for example, in our case, when the UE does a reestablishment on another DU, then we don't really know what to do with that because we are missing some information, and then we fall back to a normal RRC setup and we set up a new connection. So in a sense, it's supported because then we fall back just to normal connection setup. There are some small things that are missing to actually do this. So let's say next year.
Okay. Do you want to answer the last question or do you want to go forward?
Is there plenty of future to what OAI millimeter wave is off topic for this webinar?
Okay. So let's continue then.
Okay, now, so we saw basically the normal operation with DU and CU, and I admit it was not super exciting because, well, it works. What is maybe a little bit more interesting to look actually at F1 handover and to see this in action. And also here, not now, the demo that I will have will not be with the COTS UE, but basically it would look the same, because in the end, what I would show you in the video is the terminal output, and whether you have RF sim or real radio, it's the same. But in order to prepare us a little bit and then to maybe understand a little bit better, I will go into the details of this message exchange and also use this opportunity to talk a little bit about the measurement reports. And there was a question just now with this A3 events. So basically what will happen when we now have handover, imagine, picture again, this image of multiple DUs that we were seeing in the beginning and one CUCP on the top. And you have the UE that walks from one DU to another. And in order to now help the base station to know when it needs to hand over the UE periodically sends a measurement report, and then the DU receives this, and then again we see the uplink RRC message transfer, and it just forwards to the CU, and it says what is the channel quality. So in this measurement report, there might be either periodical measurements, also from neighboring base stations, or there might be this A3 event. So what you know based on the handover decision is not really specified. I would go as far and say I mean, basically the handover decision always originates at the network, so at the CU, so it doesn't even need the measurement report. That's what we will use in the demo in a moment, and we can also just trigger by ourselves the handover. Actually, the network can do with the UE whatever it pleases. So, but typically in a real network, there are these measurement reports, and at some point the CU will see, oh, it would be better to hand over this UE to another DU because there it has much better signal. So, and now let's leave this here aside, what is marked with 2A and 2B, so this is optional, but what will truly happen is that the UE is at the source DU, but is better served by the target DU, so the CU sees this, and it needs to now set up something, so it will send up the UE context setup request to this target DU and ask, can you handle this UE? So, and then the DU might reject this under specific circumstances, of course, but typically it will say, yes, I can. And in this case, it will send back this UE context setup response. And then the CU already knows, okay, on this DU, everything is prepared to now receive this new UE. And if this is the case, then the CU will send now this UE context modification request. So this is what we didn't see before, but we now modify the UE context because in particular, we say that at some point the DU, the source DU need to stop scheduling this UE. Before that, in this UE context modification request, we also have the RRC reconfiguration, which is basically the message that tells the UE that it needs to hand over. So it sends this, the DU sends the RRC reconfiguration to the UE, and then afterwards it basically stops scheduling that UE. Afterwards, once it has done this, it will also answer with the UE context modification response so that it has done everything properly, and that's it. And now the UE received the RRC reconfiguration, in which it basically is being told to please hand over to this other DU. That it typically will know because in the measurement report, the UE told that it sees this other target DU better, so it doesn't come completely unprepared. So what the UE then does is the random access procedure that we all know. And then once this has been done, so basically it's synchronized to this new DU, and the target DU already knows the UE, then it will send this RRC reconfiguration complete. That is basically the answer to this previous RRC reconfiguration. And via the target DU, this will be sent up to the CU. And at that point, the CU knows that the handover has succeeded. And finally, we see the UE context release command that we also didn't see before, because of course at the source DU, the UE context is still there. So basically the CU tells the source DU, delete this UE. Now, here are a couple of optional things that are not necessarily done in all cases and or not done by OAI. There is some handover tutorial where you then can actually read and also see the steps that I will show you in a moment. And if you in particular want to see more exactly what OAI does when it has and receives these different messages, then there is also some developer documentation in which basically there's more information of what happens where. Okay, so in particular on the CU side, if you want to see what happens when there is a measurement report, it's written in this developer documentation. So, and with that, we can now come to the handover demo. So I just want to say there was already an initial version of handover last year, but there were a couple of problems. So the first thing was that the configuration was very cumbersome. There were also a couple of illogical things that were happening that were not really useful, and traffic was unreliable or doesn't really work and so on. And the basic thing is with all this work that I already detailed in the various merge requests before, none of this should be a real issue. Of course, there's still some limitations for the handover, but not in the sense of the traffic doesn't work afterwards. Anyway, and with that, I go to my video and I will go here to the next one, and we now will see handover. So I have split this screen into six terminals. In the top left, we will see the CUCP. So basically the same thing that we were also seeing before. Then just below, we will start the CUUP. So it will be the same CUUP that will send traffic either to DU1 or DU2, between which the DU will hand over. And now also here, we see the same thing as before, the CUUP setup request and F1 setup request and response. So anyway, until here, nothing new. We connect the UE, it connects. We see the same output as before. Now we also see again the output that we saw before with all these uplink, downlink, RSC messages. And in particular, now this time we also see the E1 and F1 messages in the right order. So if you look at this later on, or if you do this the same, you should see the same order of what I discussed previously. Now we can continue. And the first thing that I will do is actually start the ping just to see, again, this works. We have user plane traffic. And now I will start the second DU, which will now then also be brought up. So the UE will see both. There's, by the way, one thing that I forgot. So I already said that the OAI or the GNOB can do handover with COTS UE. The OAI UE still has some limitations, okay? So I wouldn't go and as far as say that handover works reliably. It can be used, for example, here in this case, but you will see some warnings and so on where there's still a little bit of work that is necessary to do a handover. And then in particular, measurement reports and these kind of things are not implemented on the UE side, only on the GNOB side. But nevertheless, we can use it for these kind of examples here and to see what happens. And for example, also for me during development, when I was working on that, that was extremely useful. So now I said there are no measurements, so we need to manually trigger the handover, and this is what I do here. In OAI, we have a small telnet interface, which is sometimes handy, so you can just send a command, and basically we will send a command here that you see on the bottom left. We will go to the CUCP and we will just say, please hand over the UE. So I said on the bottom right, we see the UE, which will keep running, and we see on the top right and middle right windows the two DUs. And the one thing once I send on the bottom left is that the output will change, and basically you will see the UE context that is on the top one and then in the middle. Just you need to look there, and that's basically the handover. That's also what you would see if you use COTS UE. It would look exactly the same. So yes. So you see some warnings, as I said before. This is basically because there's still a couple of things, various things missing, but we see that the ping works. And in particular, if we now go into the Wireshark, we see here some message exchange, which starts with the F1 setup request of the second DU. And then we have the exchange, which is exactly the same what we saw, what I discussed before in this message exchange in this diagram, in the sequence diagram, okay? So for those who want to have a look and understand this a little bit better, you could then go. You can also then look into what are the actual message contents to maybe understand this a little bit. All of these would, of course, be feasible. So if we can do handover in one direction, we can of course do it also in the other direction, and then we can keep going and do some ping, and then because it was so much fun to do handover, we do it yet once more. Yeah. One thing that I would like to take your attention to, what you see already in the CUUP, there are some repetitive messages. So we now did a couple of handovers, and basically each time the CUCP just tells the CUUP that the destination DU for forwarding traffic changed. And now you see here these IP addresses, which is not in the typical format, but in well, in hex. And basically you see that it always switches between two addresses, which are the two DUs. So that is already one way of seeing only on the CUUP that there is some handover going on, because basically the destination addresses have always changed. Then we could also see this in Wireshark, but it's a bit confusing. There is a final way of how you can see this. What I will do now is I will just trace some UDP traffic and trace more precisely GTP. So GTP is the format or the protocol that is used to forward, to encapsulate the IP traffic of a UE between the DU and the CUUP, and also between the CUUP and the UPF, by the way. And what we will see is now that the exchange is between IPs that end on 13 and 5. And of course, if we then later do the handover, so I will go back. So here 13 and 5, as I said, then we will go back, we trigger handover, we do again a ping. So we see there is still connectivity, and if we go back, then it's now not between 13 and 5, but 13 and 4. So the IP address ending on .13 is the CUUP, and the .4 is the second DU. And then if we go back once more, we do handover, and we do traffic, we go back, and now we see again between 13 and 5, and so on and so on. And that concludes the second demo. So what you have seen is the handover, where we hand over the UE from one DU to another DU. The CUCP, the anchor in a sense, the control plane anchor remains the same. The CUUP also remains the same, but of course it needs to switch between the two DUs each and every time. Yes, and the final thing, there was the question, would this also works with COTS UE? Yes, it would. So you need to set up, you maybe need some spacing and so on. And actually that is also a good occasion for me to come back once more. Why do we need to actually use F1 and E1 internally in monolithic? So there is kind of, how to say, when I was working on that, of course, starting each time CUCP and then CUUP and testing this is a little bit cumbersome. And I included the CUUP here in this demo because it's nice to see message exchange. It's nice to see that it all works. But actually, when I was working on handover, I never tested this. Okay, so I basically used the E1 message primitives, where the RRC tells the PDCP to maybe send to another DU or something like that. Okay, so basically to make the switch between the DUs. But the E1 part I never tested. I just assumed it would work. And then later, when I prepared here this webinar, I told myself that it would maybe be nice to test with E1. So I set up a separate CUUP and a separate CUCP, and because the E1 logic is used internally, then it just worked, and I didn't need to test anything. E1 was just doing its job. Okay, so that is another reason of why F1 and E1 are used internally, because if it works in monolithic, it will also work in the split mode. So are there some questions?
Yes, so we have 2 or maybe 3 questions. The first one is, are both enter and traffic HO supported?
So for COTS UE, what we suppose as of now is interfrequency handover. What you actually saw in the demo right now in RFSIM was intra-frequency handover. The G-Node B doesn't really care that much, because in the end there are two DUs, they send somewhere, it sends something and it receives. But for COTS UE, the intra-frequency handover might not work as well, because there are like more things such as measurement gaps and various things that are missing. So officially, interfrequency handover is supported. You can also try with intra-frequency handover, but I would declare this as not working because some things are missing. So, and also next year, I guess we will come to have this working.
Okay, next question is how large is the interruption time due to handover?
Well, as we have seen, not that big. It works a little bit slow in RFSIM because we have like basically one UE that is connected to two DUs, so everything runs a bit slower. If you run this with COTS-UE, then it's a bit of 200 milliseconds, maybe 500. I mean, fast, under 1 second. I don't know whether this, I mean, or fast, I don't know whether it's the definition of fast, but under 1 second, let's say.
Okay, then we have a message from Tucker. Hello, Robert Raphael. Firstly, thank you very much for the webinar and a few questions. The first question is how many GNode BCU and GNode BDU instances can I set up within the OAI?
I never tested more than, no, actually. So what we saw in the first part of the demo is 3 DUs. In the second part with handover, and the only thing I ever tested is with 2 DUs. The internal, how it's written internally is that it can handle NDUs, so it doesn't really matter. But in particular for handover, I never really tested. But in theory, N.
Okay, then also if possible, how many RRC connected NRUE instances is possible?
Well, also here the CUCP and the RRC doesn't care, and also PDCP and RRC, they don't care. There is a limitation in the DU. I mean, by default, and as of now, it's 16, and the CI also runs with 16 UEs. Then you can extend this to 32 or 64 under conditions, let's say like this. Yeah, I hope this answers the question.
And then what does the handover trigger over telnet do?
Yes.
Yes.
What the telnet command does call the function that would normally be called if the CU received an A3 event. It calls the function that triggers handover. So I mean, basically in this telnet interface, there's a little function, and this knows where to call into the RRC, and it just says for this UE trigger handover. So I mean, it triggers a handover.
Okay, last 2 questions. Is it possible to do intra-DU-HO as well as by creating 2 cells?
Oh, the OAI DU as of now supports only 1 cell. So.
And then the last question is, can I use this procedure also to establish dual connectivity?
So NRDC, so NR dual connectivity, where both cells do NR, is not supported.
Okay, so I think we don't.
And I mean, basically also for dual connectivity, if we have NSA, so dual connectivity between LTE and NR, and I mean, then basically the handover support needs to be in LTE, and there's some code for X2 handover and so on, but I didn't try this. So what we saw now is 5G only.
Last question, have you tried doing handover between a DU with Penetel RU and a DU with Lighton RU?
Me personally, I did not try this. Maybe I hope we will do this soon. I don't see a reason of this not working, but for example, earlier there was a question of how far do the B200s need to be from each other. And for Bennett, I mean, since this is ORUs with more power and so, these RUs need to be further from each other to reliably trigger this A3 event and so on, but there is no reason why this should not work. I mean, I didn't try, but I strongly suppose it will work.
Okay, so there is no other question. Do you have a last word to say?
I have actually, yes. So, I mean, we saw now what has been done and so on, future work. There are more unit tests that will come both on F1 and E1 to make this a bit more robust and to make this work reliably. I also just mentioned NSA. So in NSA, we actually do not use the F1 handover, and that's why it works also so. So there's more work that can be done. Also, there are, let's say, issues or limitations for handover, which are described in this issue 855, and there are more things that can be done according to F1. So initially, I thought that F1 is simple, but I mean, actually not that much. It's simple to understand the basics, but then in best 3GPP manner, it gets very quickly very complex, okay? And in particular, F1 is huge, actually. It's just that we use only 10%. And yes, and yeah, then in particular for the F1 user plane, the F1 use, so the user plane part on F1, there are still also some limitations where, for example, some packet loss can lead to connection loss. And so on. I mean, basically, of course, once you have a part of 3GPP that is working, there is at least the same amount of more work that you can still do. So, but anyway, you have seen F1 handover, F1 and E1 interfaces, and so on. I thank everybody for their attention. We already went over some questions. We are also past the time. So I guess we conclude, right?
Yes.
Thank you all. Talk to you in another webinar. Have a nice day. Bye.
Bye. Thank you, Robert.